Hey everyone, this is Tim Wagner, and my group members are Chris Cogliano, Kirk Hobson, and Jake Perkins. We designed a toy for children with the goal of getting them more interested in STEM.
According to the Harvard Gazette, as the demand for STEM jobs in the workforce increases, the amount of high school graduates being prepared for STEM majors fails to keep up. To help combat this problem, a children's toy was designed to help introduce the concept of conservation of angular momentum, a fundamental law of physics which is an applicable subject to numerous STEM fields. Exposing this concept to children at an earlier age is beneficial for their development and understanding the STEM field in the long run, even into early adulthood. TAMMY, the angular momentum modular yoke, serves to fulfill this purpose. This toy is guaranteed to grab any kid's attention and get them excited to learn about angular momentum before they even enter middle school. TAMMY features adjustable weighted screws and a rotating base, so that kids can easily experiment and conceptualize angular momentum by attaching different objects to the product. This product focuses on being functional, safe, reliable, and manufacturable. The design resembles a popular product already on the market. However, TAMMY offers an educational benefit with replaceable and adjustable parts. Offering kids a toy, science experiment, and an opportunity to learn all in one compact package, TAMMY blows its competition out of the water.
The manufacturing process for this toy was designed to be simple and inexpensive. The tooling requirements are easy to obtain, with the TAMMY requiring only a 3D printer, a M5 0.8 male thread tap, and a simple press to install the bearing. The simplicity of the design ensures a lower production cost and a high-quality product. Using 3D printed ABS filament for the body, an inexpensive bearing, and steel nuts and bolts helps achieve the simple and inexpensive goal for this toy. TAMMY's design consists of a strong, shielded ball bearing connecting the handle to the cylindrical spinning body with a central bolt. Dimensions were chosen to provide the best combination of weight and strength while remaining usable for kids' smaller hands. Using bolts in varying lengths but the same M5 0.8 thread pitch gives users many options to pick from to obtain their desired length.
After the first few prototypes, a handle was proposed to easily hold the device and spin the upper portion with ease. The upper portion will center around a replaceable press-fit bearing, so once its life cycle of 10 years has come to an end, it can easily be replaced for many more revolutions. The toy is meant to be spun initially by flicking one end. As such, with intended use, it would be expected that an area of high stress concentration is where the bearing outer race contacts the inner diameter of the toy's body. However, since all that force is aligned with the rotation of the bearing, almost no stress is created. An additional problem, which was accounted for, was the forces created by dropping the toy. These forces ended up being 50 newtons, a bit over 10 pounds of force. The shaft diameter was oversized accordingly based on these factors to give a factor of safety of 1.5 for the shaft diameter that the bearing rides on. The threads of the bolt and body are unlikely to fail so long as the bolts are hand-tightened and made of steel. The bolt could cause failure due to incorrect thread length of the handle and the body, so analysis of the thread depth was done to make sure that there are adequate threads to hold the bolts in place. A final bolt length of 30 millimeters was used. The bearings used in the toy are the same used in skateboards. These bearings have undergone rigorous testing to ensure that they will withstand the forces applied to them by a skateboard rider. The calculated force on the design would be less than 50 newtons, with the bearing being capable of withstanding 1.37 kilonewtons of load. This gives the design approximately a factor of safety of 31.9. A simple toy has a less likelihood of failure and makes it borderline indestructible. TAMMY, the angular momentum modular yoke, serves to educate children with engaging experiments so as to create further interest in the STEM fields. TAMMY does this with its exciting design, which allows students to experiment with angular velocity and momentum in a new and unique way. It features durable, inexpensive, and easy to manufacture design built with off-the-shelf parts that encourage further development and experimentation at a lower cost of production. The design has been through rigorous testing, which allowed the weak points in TAMMY to be addressed and reinforced with stronger materials to improve the design. Despite this, it is worth addressing that future iterations of TAMMY could improve on design
by removing potential hazards from the product and improving the production practices used when manufacturing TAMMY.